Here's one more definition for this section. So let XD be a metric space and let A be a non-empty subset of X. Let X be a point of X. Then the distance from the point X to the set A is defined to be the greatest lower bound of the distances between X and Y such that Y is an element of A. So as an example, let's consider the set we looked at above. The open interval -1 to 1 crossed with the open interval -1 to 1 as a subset of R squared, then what is the distance between the point 3, 2 and the set A in this set in the Cartesian plane with part A, the usual metric, and part B, the max metric? So again, just pause and quickly think about that, draw that out on a piece of paper. Okay, so in the usual metric, of all points that we could select in A, what is the lower bound for the distances between this point 3, 2 and any point in A? Well, there is a lower bound. For example, none of these distances is less than 0, so 0 is a lower bound. Is there anything larger? Yes. So in this case, if we think about the point 1, 1, which is not an element of A, but is on the edge of A, we see that that point 1, 1 is closer to the point 3, 2 than any other element of A. So the distance between 3, 2 and 1, 1 would be a greatest lower bound for this set of distances. So let's see. So what is that distance in the usual metric? That distance in the usual metric would be, this is a distance of 2 in the x direction and a distance of 1 in the y direction. So this would be the square root of 1 squared plus 2 squared. This would be the square root of 5. And so that would be the distance between this point 3, 2 and the set A in the usual metric would be square root of 5. How about in the max metric? So in the max metric, again, it's going to be the maximum of the distances either in the x direction or in the y direction. And we see that each of the points in A is a minimum of at least 2 in the x direction. So that means that this distance, if we're looking at the maximum of the distance in the x direction and the y direction, this distance is always going to be greater than or equal to 2, and 2 is in fact a greatest lower bound on these distances. So the distance between our point 3, 2 and the set A is going to be 2 in the max metric.